right. Please, please do not try to do this on lined paper. If you do not have a piece of graph paper, just go back to the counter back there and grab a piece. Grab actually like a stack or like 5 to 10 because you'll need it for all these units. The problem is if you try to do this on lined paper, it's going to be hard for you to see where the solution is. So graph paper is essential. So go ahead and put a small coordinate plane on your page. Okay, I would like you to graph these two lines on the same coordinate plane. Okay, so go ahead and graph those. I'm going to walk around. Let me know if you need help getting the graph on your paper. Once you're done graphing those two lines on your coordinate plane, it's a good idea to turn to your neighbor and see if they have the same two lines. Dylan, who sits next to you? Alan. Yeah, okay. Of course I do. I hope it's gonna break. Actually, if it breaks, come back up and I'll sharpen it again. If you need a ruler, there's rulers in the bucket over there on the side counter. Hey, turn to your neighbor. Make sure you guys have the same line. All right. Now, my next question for you is, do the two equations have a common solution? And once you've answered that, I want you to tell me how you know. Okay? Go ahead and answer that question. We'll talk about it in just a minute. Lucia. I'm going to get my lines on here while you guys are answering that question. Okay, do they have a common solution? Maddie? Yes. Okay guys, everyone together, what's the solution? Right here, good. It was a little disjointed, but I heard a lot of it. This point right here, 2, 3, okay? You can see it visually when you're looking at the graph. Because remember, the graph of the lines, it's just a graph. It's like you're putting every possible solution to each of these equations, and the graph creates a line. So any point on that line is a solution to the equation. And if those lines cross, then that point right where they cross is a solution to both equations. Now we want to make sure that we did our graphing correct. So we're just going to verify it by taking this solution and putting it in for x and y for both equations and making sure that it actually does satisfy both equations. Okay, so I'm going to put in 3 for y and 2 for x here. And that's true, so we're good. Yep, we're good, okay? The checking portion of this is extremely important just because it's very easy to make graphing errors, okay? So I always check my answers and you guys need to as well. Okay, so let's go ahead and talk about, go ahead and define system of linear equations, because basically that's what we just did. We just solved a system of linear equations and we did it by graphing. You're going to be learning 2 other methods before this unit is done. And a lot of times you'll see these bracket symbols here that kind of cup those 2 equations together. When you see that, you'll know this is a system of linear equations and you're looking for a solution that satisfies both of them. Okay? So let's go ahead and define system of linear equations. I'll do one more example and then I'll have you guys try a couple before you leave. Bless you. And this is just the tip of the iceberg, you guys. Just solving them, just regular old system of equations is awesome. You're going to be solving sets of like 3 different equations with 3 variables in 3 dimensions, probably in high school. And you're also, next year in IM1, you're going to be solving systems of linear inequalities, which will be, I love it. You're going to love it too. You get to do all the shading to find out what region satisfies both inequalities. I just love it. You're going to love it. It's going to be great. Okay, so a system of linear equations is a set of 2 or more equations a solution of a system is an ordered pair, which we just saw up there. An ordered pair that satisfies both equations. Okay, so you'll see a system is just basically more than one equation. And you're finding the solution is a common point for both of them. Okay, and it's always going to be listed as an ordered pair because when you have two variables like that, you have an x and a y for your solution. So let's take a quick look. I'm going to breeze through one quick example just to solidify your understanding, and then you guys can do a couple practice problems. So this is what you're going to be given. You're going to be given this little brackety thing with two equations in it. And our method for the next couple of days is solving by graphing. So you will graph those two lines and see where they intersect, and that is the solution to your system of linear equations. So I'm going to put a coordinate plane on the paper. Yeah.
Is there a way to not graph it and just set up an equation?
Mm-hmm.
So I understand.
Definitely. I will show you next week how to do that.
Oh.
There's a couple different ways. There's actually a few different ways, but I will teach you 2 more methods next week. Okay, my first equation, my y-intercept is -1, my slope is 1. So I plot -1 and I go up 1 over 1, up 1 over 1, up 1 over 1. Now I notice that there's still some people that are struggling with making sure that their slope is negative when it's, they're having a hard time distinguishing between positive and negative slopes. So basically, you can see that this line is going in this is a positive direction and a positive direction. A positive times a positive is a positive. So this slope is positive. So if your slope is pointing up like this towards this quadrant, positive, positive, you know your slope's going to be positive. And you might say, well, then a negative slope would be down here. But let's see what happens. If you have a negative times a negative, you get a positive. So if your line is going through these two quadrants, or basically pointing towards these two quadrants, it's going to be positive. Now take a look at this though. If your line is pointing down like this is the positive direction for the x, negative direction for the y. Negative times a positive is a negative. And a negative times a positive here will be a negative. So if your line is going like this, that would be considered a negative slope. So if that helps you remember which slope is negative and which slope is positive, you can use that. Does that help for some of you? Okay. Let me graph that second line. My y-intercept is 1. My slope is -1. So I'm going to go down 1 over 1, down 1 over 1. Notice I'm going in the negative directions here. It is so common for people to struggle with slope for whatever reason. It just takes a while. You have to find a way to remember which one's which. Okay, so it looks like my solution here is going to be the point 1, 0. My x is 1, my y is 0. And I just need to confirm that by plugging it into both equations. So I'm going to plug 0 in for x and 1 in for y. So that's good. I'm going to plug in 1 for x here and 0 for y there. And that's also good. So you can confirm that this is in fact the solution to the system of linear equations. Okay. You guys good on that so far? Okay, let's flip it over. I have a couple practice problems for you to work on real quick before you leave. Thanks. All right, go ahead and graph those. Find your solutions to those, each of those systems. Hope I didn't make my coordinate plane quite big enough. Okay, make sure once you find the solution that you just check it real quick to make sure it's good. If you get a solution and you check it and it doesn't work, then you probably made an error in your graphing. So then just double check your graph, make sure it's good.
If like the problem doesn't line up with the use of them.
I'm just gonna throw the line up here, the lines up here so you can see. Looks like most people for that first one got the 0.33, which if you check it, it should be correct. The good news is it seems like graphing seems to be clicking for you guys because I walked around and your graphs look awesome. Okay, and that second one you should have gotten the 0.34. Okay, go ahead and get packed up because that bell's gonna ring in a minute. I'll be here after school if you guys need any